This is actually Unit 4.6. And while 4.6 isn't directly assessed on the AP test, there is a lot about it that we need to be able to understand to help us better understand and read graphs. So let's take a look at the basics. In order to graph a function, first we look at the domain and any intercepts. Then we identify the asymptotes and what happens at the end of the graph. Then we look at the derivative and find the critical numbers. Determine the slope of the tangent line and the critical numbers. Also, we look at the second derivative. We use the first derivative to find where the function is increasing and where the function is decreasing. And then we decide if we have mins or maxes using the first derivative. Finally, we look for concavity using the second derivative. And then we put a graph together, plotting all the points that we have. Now this is useful for finding the shape of a function, not necessarily for finding exact points all along the function. So let's take a look at what I mean. We're going to do example 1 from 4.6. So on page 341, the first thing we're going to do is to figure out what my domain is. So my domain looks like it's all real numbers. And then I'm going to look for my y-intercepts and my x-intercepts. So 3x to the fourth minus 8x cubed equals 0. Well, that's going to happen. Let's see, I'll factor out 3x minus 8. So we have x equals 0 and x equals 8/3. Those are my x-intercepts, and my y-intercept is going to happen at 0, 0. Now, since I have just a regular polynomial, I don't have any asymptotes to worry about. So my next step is going to be to find the derivative. My first derivative is 12x to the third minus 24x squared. Let's set that derivative equal to 0 and we'll find our critical numbers. So 12x squared minus x minus 2. So we have x is 0 and x equals 2. And then I'm going to make my little graph, my little chart that will help me know where I'm increasing and where I'm decreasing. So less than 0, let's plug in like a -1. I'm going to have a positive times a negative, that'll be a negative. Let's plug in the number 1, that'll be a positive times a negative, which is also a negative. And then let's plug in the number 3, that'll be a positive times a positive, which is a positive. So I know that my function is decreasing from negative infinity to 2 and increasing from 2 to infinity. So I just zoomed out for a little bit more space. I know that this is going to be a min. My min will be at x equals 2. And if I want to find the point of my minimum, I'm going to need to plug it into my original function. So let's see what f of 2 is. 3 times 2 to the fourth minus 8 times 2 cubed. -16. Now let's take a look and find our second derivative. 36x squared minus 48x. Again, we'll set this equal to 0, and let's see, we can factor out a 12 and an x, and we get 3x minus 4. We'll set that equal to 0, and we get x is 0, and x equals 4/3. Now let's do another chart and find my concavity. So 0 and 4/3. Let's plug in a -1. So I get a negative times a negative will be a positive. We'll plug in 1. That'll be positive times a negative, which is negative. And then let's plug in like 5. Positive times a positive is positive. So that means I know that I'm concave up from negative infinity to 0 and from 4/3 to positive infinity. And I'm concave down from 0 to 4/3. Now, I want to make a point here. We haven't really talked about this, but it's an important point to make. 0 looked like it was going to be a critical point, but it wasn't because it was negative before and after 0. But what I did find out that 0 was actually a point of inflection. That's really important. Not always, but very often, our graphs switch signs, negative, positive, negative, but in this case we went negative, negative, positive. If my concavity didn't also switch at 0, I would be a little bit concerned that maybe I plugged in wrong into the critical numbers into the first derivative. So it's something to be cognizant of. So with that said, let's go and graph now. So let's see, we have 0, 0, and then 8/3 is going to be another point. And then, let's see, 2 is going to be negative 16. And 4/3 is going to be something that I want to pay attention to. So I'm going to put 4/3 on my picture. And 0. So let's see what's happening. I'm decreasing from 0 to 2, but at 0, I change from positive concavity to concave up from concave down. So let's see. That's going to be concave up from negative infinity to 0 and decreasing. So we'll look something like that. And then at 0 until 2, I'm still decreasing, but I change concavity to concave down. And then at 4/3, I change it to concave up. So that's concave down, and then concave up, like that. So I'm going to have a function that looks something similar to this. So let's do one more example. Again, the important part about this is not necessarily that you make a perfect graph, but that you understand how all of the first derivative test and the second derivatives all come together and what they are able to show us as a whole picture. So 0 is not part of my domain. My domain is going to be all real numbers except x equals 0. So I'm going to have something going on there at x equals 0. So let's see what's happening. To find my asymptotes, let's take the limit as x goes to 0. As x goes to infinity, of 6x squared minus 6 over x cubed. And that's going to be, because I'm going to infinity, it's going to be 1 over x, which is just going to be 0. So I know that y equals 0 is going to be an asymptote. Now to find my vertical asymptotes, I'm going to be using this all real numbers except x equals 0. So let's take the limit as x goes to 0 from the left of our function, and the limit as x goes to 0 from the right of our function. From the left, we're going to get positive infinity, and from the right, we're going to get negative infinity, meaning that x equals 0 is also an asymptote. All right, now let's get into our derivatives. So to find my first derivative, I have a u and a v. So 6x squared minus 6, and my v is x cubed. My u prime, 12x, and my v prime is 3x squared. So my first derivative is 12x times x cubed minus 3x squared times 6x squared minus 6 all over x cubed. So I should spend a little bit of time reducing this and simplifying it in order to make the next step a lot easier. So 12x to the fourth minus 18x to the fourth plus 18x squared. So we get negative 6x to the fourth plus 18x squared over x cubed. Now remember, when I'm looking at my first derivative, I'm going to be worrying about when my derivative equals 0 and when it does not exist. So that my numerator I'm going to set to 0, and then I'm going to set my denominator to 0. So let's factor 6x squared out of my numerator. I'm going to get negative x squared and plus 3. And we'll set each of those equal to 0. So 6x squared equals 0. So x is 0. And I'm going to get x squared plus 3. So negative x squared plus 3 equals 0. So then x squared equals 3. And x is going to be the plus or minus the square root of 3. And then for my denominator, where it does not exist, x cubed equals 0. So x equals 0. So I'm going to get 3 critical numbers this time. So let's keep going and work on our critical numbers and where we're increasing and where we're decreasing. So we have 0, square root of 3, negative square root of 3. So let's plug in negative 2. That's going to be negative 6 times 16, which will be negative 96, and then 18 times 4 is 72. So I'm going to have a negative on my numerator and a negative on my denominator, so that's a positive. If I plug in negative 1, I'm going to have negative 6 plus 18, which is positive, over 1 cubed, which is negative, so negative. And if I plug in positive 1, I'm going to have positive in the numerator, positive in the denominator. And then square root of 3, if I plug in positive 2, I'll have negative in my numerator and positive in my denominator, so negative. So I know that we're increasing from negative infinity to negative square root of 3, and from 0 to square root of 3. And then we're decreasing from negative square root of 3 to 0, and from the square root of 3 to infinity. Let's take a look at my second derivative and find my concavity. I'm going to be using this simplified version to help me find my second derivative. Again, it will be a u and a v. So my numerator is my u, negative 6x to the 4th, plus 18x squared, and my v is x cubed. U prime is negative 24x cubed plus 36x, and my v prime is 3x squared. My second derivative, negative 24x cubed plus 36x, all times x cubed, minus 3x squared times negative 6x to the 4th plus 18x squared, everything over the original squared, so that's going to be x to the 6th. Let's simplify my numerator. I have negative 24x to the 6th plus 36x to the 4th minus 18x to the 6th plus 18x to the 6th, and then minus 54x to the 4th, all over x to the 6th. Again, we can simplify some more here. So we're going to get negative 6x to the 6th, and for x to the 4th, we have a negative 54 and a positive 36 is going to be negative 18x to the 4th, all over x to the 6th. So now let's see where our second derivative does not exist and where our second derivative is equal to 0. So we'll set our numerator equal to 0, and we'll set our denominator equal to 0. We're going to get x equals 0 for one point, and then for the other point, let's see if we factor out a negative x to the 4th, negative 6x to the 4th, I'm going to have x squared and minus 3. So I'm going to get x equals 0 from this side, and x squared equals 3, so x is going to be plus or minus the square root of 3. And we're going to set up our same chart and find our concavity this time. All right, I'm going to be plugging into this equation right here. And if I plug in a negative 2, I get a negative in my numerator and a positive in my denominator, so that's a negative. So if I plug in negative 1, I'm going to have a negative in my numerator and a positive in my denominator, so we're going to have a negative overall. And then if I plug in positive 1, I'm going to have a positive in my denominator, but in my numerator, I have a negative, so that'll be a